All right, everybody, it is our last video for this standard 4, which is complex number operations. It's a continuation from, we got two other videos that cover complex operations. We've talked about just simplifying radicals. We've talked about all the operations, adding, subtracting, multiplying, dividing, which included some rationalizing. And now we're going to talk about the different powers of I. All right, and so go ahead and get ready whenever you are. Proceed. Okay, so the powers of I. We're going to start back with just what is I, and I represents the square root of -1. So this means I to the first power is the square root of -1. We often just want to write that as I, just what it is. So then what if I take I squared? And in the last video, I explained that that'd be taking -1, the square root of -1, and squaring it, which results in -1. So I cubed would be taking I times I squared, and since I is itself and I squared is -1, then I cubed is -I. Then we take I to the fourth. Well, if I to the fourth is actually I squared times I squared, which is like -1 times -1, then that equals a +1. So we actually can make a very simple chart here that I to the first equals I squared equals -1, I cubed equals -I, and I to the fourth equals +1. So why did I stop at I to the fourth? Well, let's consider I to the fifth. And following this pattern, I would say, well, since I know what I to the fourth is, and then I'm just multiplying it by another I, well, I to the fourth is 1 times another I means that it's just I. So wait, I to the fifth is I? Let's try I to the sixth. Well, I to the sixth is like I to the fourth times I squared. And since I to the fourth is +1 and I squared is -1, then I to the sixth is -1. Well, I to the seventh. Well, that's like I to the fourth times I cubed. Well, I to the fourth is +1, and I cubed, according to my chart right here, is -I, and well, 1 times -I is -I, and I to the eighth is the same way. So I have I to the fourth times I to the fourth, which means 1 times 1, which is 1. So if you notice that when I got to 4, I started repeating the pattern, I, -1, -I, +1. You say, well, do I have to do this for no matter what exponent I get? And I say, no, I don't really think you have to do this for every exponent, because what if I gave you, I want to find I to the 210th power? I don't want to draw this out for 210. But if we can notice that, or predict that every time we end up with an I to the fourth, we actually get a 1 out of it, because I to the fourth is 1, that this actually repeats in cycles of 4. So for something not as big as that, how about we just start with like I to the 30th power? That if I consider this as I to the fourth plus times I to the fourth times I to the fourth. Now that's already 12 times I to the fourth, that makes 16. I to the fourth, that makes 20. I to the fourth makes 24. Times I to the fourth makes 28, times I to the 28. I only need 2 more. So all of these have a value of 1. They're not disappearing, they just have a value of 1. So really this ends up with I squared, which we know is -1. So this I to the 30th is -1. All right, so let's back up a little bit. That means that if I can get a bunch of 4s, what's a faster way of finding a bunch of 4s? It's division. Okay, so let's take another one. I to the 53rd. Okay, so the first thing I want to do is I want to divide this 53 and see how many perfect I to the fourths would be in it. Say, well, I don't know. How many times? What do you think? What can go in? Well, 48 would be 12 perfects. So that means 52. So you're just basically taking 53 and dividing it by 4. Let's not make it complicated. Okay, and you say, well, how many times does it go in perfectly? And the answer is that it goes in 13 times perfectly. So 13 times there are I to the fourth. So I could write out I to the fourth, I to the fourth, I to the fourth 13 times, or I can recognize that there are 13 of them, and that means that I really have 1 to the 13th power. But wait a minute, that gets me 52. It doesn't get me 53, so that means I have 1 left over. Well, if this really has a value of 1, then my final answer is I. Okay? So let's take a look at just one more of those. Let's do I to the 135th power. Okay, so once again, I want to divide this 135 by 4. I'm dividing it by 4. So whatever calculator you got around you, go ahead and take 135 and divide it by 4. And you'll see that I'll have I to the 4th power works 33 times. Well, 4 times 33 is not 135. It's 132. So this takes care of 132 of them, which means that I actually have I cubed left over. So since I don't have to worry about this because it's just a value of 1, I only have to worry about the leftovers, the I cubed. So the answer for this one, I to the 135th power, is I cubed equals negative I. The answer is negative I. All right, that's actually it. So what I want you to do is I want you to try these 4 problems, okay? So I want you to simplify them in your answers with the exception of number 3 because I put a coefficient on it. But the answers for numbers 1, 2, and 4, you really have a 1 in 4 chance of getting them correct. Your answers will be I, where if you get an I squared, it's negative 1. If you get an I cubed, it's negative I. And if you get an I to the 4th, it's positive 1. So your answers, with the exception of this one, I'm hoping you're catching on to what that one's going to be, will be one of these 4 numbers. I, negative 1, negative I, or positive 1. All right, we'll check with you the next time I see you.